Today we are going to learn the distributive property. The distributive property says that the sum of two or more addends multiplied by a number gives the same answer as distributing the multiplier, multiplying each addend separately, and adding the product together. So, we have been used to completing what's inside the parentheses and then following the order of operations. So with order of operations, we're used to PEMDAS, or please excuse my dear Aunt Sally. Parentheses, exponents, multiply and divide left to right, add and subtract left to right. With the distributive property, that tells us if we were to add the 5 plus 2 and come up with 7, and then multiply it by 3, we get 21. However, we can take that 3 and multiply it by the 5 to get 15, and multiply that 3 by the 2 to get 6, then add them together and still come up with the same answer. Both ways will work. So let's look at another example of the distributive property. In algebraic expressions, we have variables such as the x. So we can't add the x and the 3 together inside of the parentheses. However, we can distribute the 4 and multiply it by everything inside the parentheses. So to simplify this expression using the distributive property, we simply would multiply 4 times x and come up with 4x, and 4 times 3 and come up with 12. Both of these expressions mean the exact same thing. They are both equal to one another. So let's look a little bit further. Again, the distributive property enables us to simplify expressions that have expressions being multiplied by a single term. So in all of these cases, each thing on the left side means the exact same thing on the right side. This is just showing you algebraically when they take the A and they multiply it by the B and the C, they then can have AB plus AC. So let's look at it over here on the other side with numbers. 3 times the x and 3 times the 3 would be 3x plus 9. Both of these expressions are equal to each other. They mean the same thing. Again, you can do this. On this next particular example, the 5 is on the back side. It's still touching the parentheses, so it still needs to be distributed. So you still have to multiply it times each term inside of the parentheses. Same goes with the next one down. 2 times 3, 2 times 4. Keep your subtraction sign. And the last one is the same as well. I would encourage you to remember to draw your arrows every time so that you know what you have to multiply by. Here's another example, the distributive property, otherwise known as the party method. What do they mean by that? Well, when you're distributing it, you are multiplying one party, so you're taking the 6 and you're multiplying it by everything inside of the parentheses. Remember, you have to distribute it to everything inside of the parentheses. Now, what if you have an expression, we haven't got to this yet, where you have 2 sets of parentheses? Well, this is a 2-party. So in orange, they're distributing the 4 to the parentheses that it's touching, and then in green, they're distributing the 2 to what it's touching. Moving right along, late to the party. Well, in this particular problem, you notice you have 4x as a term by itself outside of the parentheses. So they bring the 4x straight down because it's not touching the parentheses. and then they distribute the -3 to each term. And last, considered left the party early. On the back side of the parentheses, you notice you have this 3x. So you only distribute the 6 to what's inside the parentheses, but the 3x just comes straight down. The last thing that we need to talk about is I can use the distributive property to express a sum of two whole numbers with a common factor as a multiple of a sum of two whole numbers with no common factor. What does this mean? Well, looking at this first example, we have 35 and 40. If we're looking at the numbers 35 and 40, we can find the greatest common factor between these numbers. What is the number that we can divide 35 and 40 both by? 5. So 35 divided by 5 is 7, and 40 divided by 5 is 8. If you remember back to the beginning of the school year, if we use the box method to factor out, whatever's on the left-hand side of the box is going to be our greatest common factor. So we know that we can factor the 5 out. So what does this mean? This means we could take the 5 out and put parentheses around the 7 and the 8. So if you were to go the opposite way and use the distributive property to check your work, 5 times 7 is 35, and 5 times 8 is 40. Both of these expressions are equal to one another, but we factored out the greatest common factor to determine or give us an expression that is the distributive property. So in this particular problems, we're going backwards. So again, we have 5 and we have 15. Well, looking at this, what could you multiply to get 5? Well, 5 times 1 would give you 5, and 5 times 3 would give you 15. So you take out the first number and put it outside the parentheses. Then you put your other numbers inside the parentheses with your addition sign. So you're factoring out. So again, if we were to use the box method, 5 to 15, we could divide both of those numbers by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So here's your problem. These would be in the parentheses. So you would have 5, 1 plus 3. That concludes our lesson.